Recently, more people have become aware of the existence of VPNs and have begun to use them in their personal lives. There are a number of legitimate reasons for people to do this, such as protecting their privacy when using an open network, and a number of illegitimate reasons, such as circumventing regional locks on streamed media. A virtual private network can be defined as a means of transmitting private data securely from one network across an unsecured network to the third network. Here, let's VPN. Oops. Let's write VPN here. This is our old illustrations. VPN here. So actually, let's make it a little bit. Okay. Zoom. So VPN. So generally speaking, the unsecured network we are referring to as the internet, which due to the nature of its design has a number of potential security risks. However, this is not always going to be the case. I worked for one organization that required the use of the VPNs within their own infrastructure. In this case, the network being transmitted was not insecure. We just needed to ensure any data that was transmitted across it was not visible to the others, even though they were from the same company. We often refer to the use of the VPNs as using the VPN tunnel. You may be wondering why companies would need to use a VPN, and that is a good question. First, let's look at a very common reason for doing so, and that is when an organization is located on multiple sites. Here, let me actually write a diagram here. So this will be our building here. So here we will have the head office here, head office, and then we will have another office here. This will be branch office. So in head office we will have two computers, for example, computer 1 and 2. Actually 1 here, okay. So this is the 1, 2 here. So this is the here. Let's add another router here. So for example, let's make this router, and then we will create another router here as well, and cloud. This will be internet cloud here. This is the internet actually let's write inside here. Actually not inside, it's good like that. So this will be internet, and we inside internet we will have tunnel, which is VPN tunnel here. This is the VPN tunnel here. So let's make internet bigger here, and tunnel smaller here. Here. So this will be the head office here. Actually, this is the head office, and this will be our branch office. here. So this will be the VPN concentrator here. VPN on here. Let's make it, for example, 16. Here, this is the VPN concentrator and the VPN concentrator also. So these computers connects to this VPN concentrator, and also this, and this connects to, and this computer connects to, and this VPN concentrator connects to the VPN tunnel. Oops. So this connects to VPN tunnel here. So as you can see here, in this actually in this virtual private network, you can see internet, which due to the nature of design, you may be wondering why companies would need to use a VPN, and that's a good question. So first, let's look at very common reason for doing so, and this is when an organization located on multiple sites. In this diagram, we can see a site-to-site VPN. So this is the office here. Actually not. Let's VPN and copy office or company building here. So in this case, the organization wants to ensure that all the traffic between the sites is protected. So they utilize VPNs to facilitate this. All the traffic from the branch offices passes through a device known as the VPN concentrator. The VPN concentrator at each site will directly connect to the VPN concentrator here with VPN tunnel at the head office, as you can see here. So the transmission of the data across the VPN is transparent to most users. That is, they are unaware that this takes place. So another common form of implementation is through the installation of a VPN client on each device, also known as the remote access VPN. When a user wants to connect to the head office, they need to open the VPN client application on their device and then authenticate with the application before they can gain access to the head office network. So this implementation is usually reserved for telecommuters or mobile users, such as sales staff or field engineers or home-based users, since the administrative overhead becomes too great. So on the user's end, they have to deploy and configure the application on each device and run the application. So you also have to rely on the user remembering their VPN credentials, which may not be the same as their domain credential. Users who are connecting remotely will be required to authenticate against some form of remote authentication server before access is granted. Let me check, is this recording? Yes, actually, yes. Before access is granted, they need to authenticate server. So here, as you can see here, we created a diagram here, and now I want to show you the remote authentication server, how they are creating. So let's copy this here, copy and paste it here. Make it little here. So this is the head office for again here. Let's copy this text here as well. Here, this is the head office, and we will have a VPN, actually not VPN. Let's, okay, it's, yeah, or not. Let's use router. Okay, this, or not, this is the VPN concentrator, and we will VPN concentrator. actually make it little. So this is the VPN concentrator, and we will actually, in this case, we will use remote authentication server here, and this will be our remote authentication server. Remote server. Here, this is our remote authentication server, and this VPN concentrator goes to remote authentication server here, and also for example, we will use TÜV computer, also goes to the first computer, for example, home based, and here we will have second computer, for example, field based. And then this actually directly goes to internet via VPN tunnel, and then these computers connects in here with this VPN tunnel, connects to the VPN here. So a VPN may also be used with an extranet to provide limited secure communications to our infrastructure for our trusted partners. In all the presenting implementations, the user's device will appear as if it is on the head office network. VPN tunnels provides data security through the use of encryption and authentication. So the methods that are used vary depending on the tunneling protocol that's used. Microsoft has used three tunneling VPN protocol in recent years. Let me write these protocols here. Actually here. So this is first is point-to-point tunneling protocol, link protocol, which tell that PPTP, and also we have point-to-point protocol, point-to-point protocol, also refer that PPP, and we have secure socket tunneling protocol, secure socket tunneling protocol, referred as SSTP. SSTP here. So the new absolute PPTP was designed to transmit PP point-to-point protocol traffic through the VPN, as you can see here. So in this case, point-to-point tunneling protocol creates a communication channel to the recipient, and that channel will then be used to create generating routing encapsulation GRE tunnel for the data to be transmitted across. So encryption was provided by Microsoft point-to-point encryption MPAE, and authentication was by password authentication protocol PAP, challenge handshake authentication protocol or THAP. So SSTP was implemented in Windows Vista. Like PPTP, SSTP was designed to securely transmit peer point-to-point, actually not point-to-point protocol, not tunneling. However, SSTP uses secure socket layer, transport layer security, so SSL, TLS, to provide encryption. It also utilizes the same network port as HTTPS traffic, so that is the port is 443. Port 443. So Since this port is usually open on firewalls for secure web browsing, so this means that the network administrators didn't need to open another port to allow the traffic through. So authentication of secure socket tunneling protocol authentication of secure socket tunneling protocol traffic was provided by MS CHAP and extensible authentication protocol TLS. Windows 7 saw the introduction of the layer 2 tunneling protocol L2TP, while L2TP provided the tunnel. So actually let me write here, note here for better understanding. Here this layer 2 tunneling protocol, layer 2 tunneling protocol, so L2TP. So while L2TP provided the tunnel, it did not provide any form of encryption. So it was usually deployed alongside Internet Protocol Security IPsec. So which does so authentication is conducted using the Internet Key Exchange IKA. So to try and overcome the issues with users forgetting to start their VPN connections, Microsoft released support for direct access in Windows 7. When a user started up their device, the direct access service running on it will check to see if it was on the same network as the direct access server. If it is discovered it was on the same network, then it knew that to use direct access as a form of VPN. So however, if it was not the same network as the direct access server, then the device will use the direct access service to make a connection to your organization's direct access server. Again, this was transparent to the user. So the additional benefit of using direct access was the administrators could manage those remote devices as if they were on the local network. With the release of Windows 10, Microsoft provided users with a service called Always On VPN, which was designed to replace direct access. Always On VPN could be configured to create a device tunnel that would connect through the VPN once the device had booted up, or could be configured to a user tunnel that connects once a user logs in. So these two options are not mutually exclusive, and but both can be implemented at the same time. However, to utilize the device tunnel, you have to use either an enterprise edition of Windows 10 or education edition. So with this, we have finished looking at basic security features of a network in our Udemy course.